Hello and welcome to another Physical Sciences 3 lecture. Today we're looking at forces and Newton's laws of motion. So a force can be described in terms of a push or a pull. They're everywhere, and this sentence just says they're very important because if there were no forces in the universe, Earth would not be able to be in its orbit around the Sun, and we would not be able to walk or even exist because objects need forces to keep their shape. So they're very important. So force is a vector quantity, which means it has a direction as well as a magnitude. The unit force, so the SI unit force is a Newton, and we represent that with a capital N. And a force is exerted by one object onto another. Okay. Effect of forces. So they can start an object to start moving, they can start an object to stop moving, they cause an object to change its speed, and cause an object to change its direction. Okay. All four of these are described by an object's acceleration. That is, forces on an object directly impact the acceleration of the object. Forces can also cause objects to change shape. However, this is not part of our course. So, if we see an object accelerating, then we can say that there is an unbalanced force acting on an object. Causes the object to accelerate. So that's the key kind of concept that you need to understand. Causes the object to accelerate or change direction. Okay. So unbalanced forces, and we'll talk about unbalanced forces later. So here's some types of forces. So there's pushes and pulls, tension, weight, and friction. They're all types of forces that we'll talk in more detail later on. The resultant force. So we've already done some maths on resultant forces. So all our vector additions, and we had a look at some resultant forces. So if we had forces acting in a couple of different ways, the resultant force would be what we would see the direction of the object moving in. So the resultant force, also called the net force, so and we say a net force there, is not a real force in terms of one object acting on another, but it is the vector sum. So it's the sum of all forces acting on a particular object. For this reason, it's best to distinguish it from other forces by using the symbol F net. Alright. Okay. If the net force is 0, then the forces on the object are said to be balanced. If the net force is not 0, then the forces are said to be unbalanced. So that's what I was kind of talking about before. So if this equals 0, then it implies balanced. F net. If it is not 0, it means that it is unbalanced. Okay, and there will be acceleration involved. So we have an example here. So we have a mass is subjected to a force of 200 newtons east and another one 200 newtons southwards. What is the resultant force? So we've already done quite a fair few of these kind of problems already. So just remember that we have north, east, south, and west. Okay, so the first one we have is 200 newtons east, 200 newtons that way, and then we have another one, 200 newtons south. And then overall, this force here, this is our F net, or it's the resultant force. So we can also call it the resultant force there. And sometimes we've labelled it as R. So R equals F net in this case. Okay, so we just go through the same process that we've seen a fair few times. So then I'm going to say F net this time. The net force is equal to the square root of 200 squared plus 200 squared. Okay, and then we put that into our calculator. I'll get my calculator up. So it is, where's my square root? There it is, 200 and 1 squared plus 200 squared is equal to 282, or 283, rounded up to 3 significant figures, 283, and that is in newtons. And then our theta, our angle, is equal to tan to the minus 1 of 200 over 200. Okay, and we should find that's 45 degrees. And it's acting in, if we go, it's east to south, isn't it? So we've gone east first, then south. So we could say it's east, south. It just so happens that it's the same as south, 45 degrees east, if we were looking at it the other way. Okay, so therefore, we could say the resultant or net force, is 283 newtons, south 45 degrees east.